I'm getting cash overseas by the boatload. You wanna ride my wave? That's a no-go. Senoritas going loco. Make it bounce like a pogo. All my haters see rojo. They big mad cause they coming up short like Frodo. Activate the beast mode. I keep it hot, give your brain a heat stroke. You ain't a big shot, you some basic B-roll. The world is mine, like my name's Pacino. Hey, it's Nico, I guess I'm back. Catch me in the fast lane on the right track. And my shorty is a 10 like a dime bag. Got me feeling like a millie, check the price tag.
Got the party jumping like crisscross. Got the gold chain and the wristwatch. Pull up on the scene like a big shot. EDM and hip-hop, ain't no time for pit stop.
Got the party jumping like crisscross. Got the gold chain and the wristwatch. Pull up on the scene like a big shot. EDM and hip-hop, it's my style.
No time for daydreams. All my brothers get money, we call it gang green. Just another day, but our focus still on the same thing. Us against everyone else, I recommend you change teams. Who the hottest in the city? We the top two. You said your music was litty, but that is not true. Just being honest, you should really just stop, fool. Matter of fact, empty no pockets, give me that watch too. My mind is wicked, that's why I spit it so hostile. Freaky girls in the crib, it's like I live in a brothel. All I spit is Leviticus, but I'm not an apostle. My nuts hang low, long and they colossal. Black trader black, she messiah to the misfits. Run circles, run these rappers till my shit splits. You a little late to the party, baby, I been lit. If you ain't on the friend list, you better mind your business. Got the party jumping like crisscross. Got the gold chain and the wristwatch. Pull up on the scene like a big shot. EDM and hip-hop, ain't no time for pit stop.
Got the party jumping like crisscross. Got the gold chain and the wristwatch. Pull up on the scene like a big shot. EDM and hip-hop, it's my style. Juice like a snow cone. Ice in my veins and a cold flow. I'm getting cash overseas by the boatload. You wanna ride my wave? That's a no-go. Senoritas going loco. Make it bounce like a pogo. All my haters see rojo. They big mad cause they coming up short like Frodo. Activate the beast mode. I keep it hot, give your brain a heat stroke. You ain't a big shot, you some basic B-roll. The world is mine, like my name's Pacino. Hey, it's Nico, I guess I'm back. Catch me in the fast lane on the right track. And my shorty is a 10 like a dime bag. Got me feeling like a millie, check the price tag.
Got the party jumping like crisscross. Got the gold chain and the wristwatch. Pull up on the scene like a big shot. EDM and hip-hop, ain't no time for pit stop.
Got the party jumping like crisscross. Got the gold chain and the wristwatch. Pull up on the scene like a big shot. EDM and hip-hop, it's my style.
No time for daydreams. All my brothers get money, we call it gang green. Just another day, but our focus still on the same thing. Us against everyone else, I recommend you change teams. Who the hottest in the city? We the top two. You said your music was litty, but that is not true. Just being honest, you should really just stop, fool. Matter of fact, empty no pockets, give me that watch too. My mind is wicked, that's why I spit it so hostile. Freaky girls in the crib, it's like I live in a brothel. All I spit is Leviticus, but I'm not an apostle. My nuts hang low, long and they colossal. Black trader black, she messiah to the misfits. Run circles, run these rappers till my shit splits. You a little late to the party, baby, I been lit. If you ain't on the friend list, you better mind your business. Got the party jumping like crisscross. Got the gold chain and the wristwatch. Pull up on the scene like a big shot. EDM and hip hip-hop, ain't no time for pit stop.
Got the party jumping like crisscross. Got the gold chain and the wristwatch. Pull up on the scene like a big shot. EDM and hip-hop, cause my style. Overseas by the boatload. You wanna ride my wave? That's a no-go. Senoritas going loco. Make it bounce like a pogo. All my haters see rojo. They big mad cause they coming up short like Frodo. Activate the beast mode. I keep it hot, give your brain a heat stroke. You ain't a big shot, you some basic B-roll. The world is mine, like my name's Pacino. Hey, it's Nico, I guess I'm back. Catch me in the fast lane on the right track. And my shorty is a 10 like a dime bag. Got me feeling like a millie, check the price tag.
Got the party jumping like crisscross. Got the gold chain and the wristwatch. Pull up on the scene like a big shot. EDM and hip-hop, ain't no time for pit stop.
Got the party jumping like crisscross. Got the gold chain and the wristwatch. Pull up on the scene like a big shot. EDM and hip-hop, cause my style.
No time for daydreams. All my brothers get money, we call it gang green. Just another day, but our focus still on the same thing. Us against everyone else, I recommend you change teams. Who the hottest in the city? We the top two. You said your music was litty, but that is not true. Just being honest, you should really just stop, fool. Matter of fact, empty no pockets, give me that watch too. My mind is wicked, that's why I spit it so hostile. Freaky girls in the crib, it's like I live in a brothel. All I spit is Leviticus, but I'm not an apostle. My nuts hang low, long and then colossal. Black trader black, she messiah to the misfits. Run circles, run these rappers to my shit splits. You a little late to the party, baby, I been lit. If you ain't on the friend list, you better mind your business. Got the party jumping like crisscross. Got the gold chain and the wristwatch. Pull up on the scene like a big shot. EDM and hip-hop, ain't no time for pit stop.
Got the party jumping like crisscross. Got the gold chain and the wristwatch. Pull up on the scene like a big shot. EDM and hip-hop, cause my style. Juice like a snow cone. Ice in my veins and a cold flow. I'm getting cash overseas by the boatload. You wanna ride my wave? That's a no-go. Senoritas going loco. Make it bounce like a pogo. All my haters see rojo. They big mad cause they coming up short like Frodo. Activate the beast mode. I keep it hot, give your brain a heat stroke. You ain't a big shot, you some basic B-roll. The world is mine, like my name's Pacino. Hey, it's Nico, I guess I'm back. Catch me in the fast lane on the right track. And my shorty is a 10 like a dime bag. Got me feeling like a millie, check the price tag.
Got the party jumping like crisscross. Got the gold chain and the wristwatch. Pull up on the scene like a big shot. EDM and hip-hop, ain't no time for pit stop.
Got the party jumping like crisscross. Got the gold chain and the wristwatch. Pull up on the scene like a big shot. EDM and hip-hop, cause my style.
daydreams. All my brothers get money, we call it gang green. Just another day, but our focus still on the same thing. Us against everyone else, I recommend you change teams. Who the hottest in the city? We the top two. You said your music was litty, but that is not true. Just being honest, you should really just stop, fool. Matter of fact, empty no pockets, give me that watch too. My mind is wicked, that's why I spit it so hostile. Freaky girls in the crib, it's like I live in a brothel. All I spit is Leviticus, but I'm not an apostle. My nuts hang low, long and then colossal. Black trader black, she messiah to the misfits. Run circles, run these rappers to my shin splits. You a little late to the party, baby, I been lit. If you ain't on the friend list, you better mind your business. Ooh, got the party jumping like crisscross. Ooh, got the gold chain and the wristwatch. Ooh, pull up on the scene like a big shot. EDM and hip hop, ain't no time for piss stop. Ooh, got the party jumping like crisscross. Ooh, got the gold chain and the wristwatch. Ooh, pull up on the scene like a big shot. EDM and hip hop, it's my strong. Juice like a snow cone, ice in my veins and a cold flow. I'm getting cash overseas by the boatload. You wanna ride my wave? That's a no-go. Senoritas going loco, make it bounce like a pogo. All my haters see rojo, they big mad cause they coming up short like Frodo. Activate the beast mode, I keep it hot, give your brain a heat stroke. You ain't a big shot, you some basic B-roll. The world is mine like my name's Pacino. Hey, it's Nico, I guess I'm back. Catch me in the fast lane on the right track. And my shorty is a 10 like a dime bag. Got me feeling like a millie, check the price tag. Got the party jumping like crisscross. Got the gold chain and the wristwatch. Pull up on the scene like a big shot. EDM and hip hop, ain't no time for piss stop. Got the party jumping like crisscross. Got the gold chain and the wristwatch. Pull up on the scene like a big shot. EDM and hip hop, it's my style. No time for daydreams. All my brothers get money, we call it gang green. Just another day, but our focus still on the same thing. Us against everyone else, I recommend you change teams. Who the hottest in the city? We the top two. You said your music was litty, but that is not true. Just being honest, you should really just stop, fool. Matter of fact, empty no pockets, give me that watch too. My mind is wicked, that's why I spit it so hostile. Freaky girls in the crib, it's like I live in a brothel. All I spit is Leviticus, but I'm not an apostle. My nuts hang low, long and then colossal. Black trader black, she messiah to the misfits. Run circles, run these rappers to my shin splits. You a little late to the party, baby, I been lit. If you ain't on the friend list, you better mind your business. Ooh, got the party jumping like crisscross. Ooh, got the gold chain and the wristwatch. Ooh, pull up on the scene like a big shot. EDM and hip hop, ain't no time for piss stop. Ooh, got the party jumping like crisscross. Ooh, got the gold chain and the wristwatch. Ooh, pull up on the scene like a big shot. EDM and hip hop, it's my strong. Juice like a snow cone, ice in my veins and a cold flow. I'm getting cash overseas by the boatload. You wanna ride my wave? That's a no-go. Senoritas going loco, make it bounce like a pogo. All my haters see rojo, they big mad cause they coming up short like Frodo. Activate the beast
Pacino. Hey, it's Nico, I guess I'm back. Catch me in the fast lane on the right track. And my shorty is a 10 like a dime bag. Got me feeling like a milli, check the price tag.
Got the party jumping like crisscross. Got the gold chain and the wristwatch. Pull up on the scene like a big shot. EDM and hip hop, ain't no time for pit stop.
Got the party jumping like crisscross. Got the gold chain and the wristwatch. Pull up on the scene like a big shot. EDM and hip hop, cause my style.
No time for daydreams. All my brothers get money, we call it gang green. Just another day, but our focus still on the same thing. Us against everyone else, I recommend you change teams. Who the hottest in the city? We the top two. You said your music was litty, but that is not true. Just being honest, you should really just stop, fool. Matter of fact, empty no pockets, give me that watch too. My mind is wicked, that's why I spit it so hostile. Freaky girls in the crib, it's like I live in a brothel. All I spit is Leviticus, but I'm not an apostle. My nuts hang low, long and they're colossal. Black trader black, she messiah to the misfits. Run circles, run these rappers till my shit splits. You a little late to the party, baby, I been lit. If you ain't on the friend list, you better mind your business. Got the party jumping like crisscross. Got the gold chain and the wristwatch. Pull up on the scene like a big shot. EDM and hip hop, ain't no time for pit stop.
Got the party jumping like crisscross. Got the gold chain and the wristwatch. Pull up on the scene like a big shot. EDM and hip hop, cause my style. Juice like a snow cone. Ice in my veins and a cold flow. I'm getting cash overseas by the boatload. You wanna ride my wave? That's a no-go. Senoritas going loco. Make it bounce like a pogo. All my haters see rojo. They big mad cause they coming up short like Frodo. Activate the beast mode. I keep it hot, give your brain a heat stroke. You ain't a big shot, you some basic B-roll. The world is mine like my name's Pacino. Hey, it's Nico, I guess I'm back. Catch me in the fast lane on the right track. And my shorty is a 10 like a dime bag. Got me feeling like a milli, check the price tag.
Got the party jumping like crisscross. Got the gold chain and the wristwatch. Pull up on the scene like a big shot. EDM and hip hop, ain't no time for pit stop.
Got the party jumping like crisscross. Got the gold chain and the wristwatch. Pull up on the scene like a big shot. EDM and hip hop, cause my style.
No time for daydreams. All my brothers get money, we call it gang green. Just another day, but our focus still on the same thing. Us against everyone else, I recommend you change teams. Who the hottest in the city? We the top two. You said your music was litty, but that is not true. Just being honest, you should really just stop, fool. Matter of fact, empty no pockets, give me that watch too. My mind is wicked, that's why I spit it so hostile. Freaky girls in the crib, it's like I live in a brothel. All I spit is Leviticus, but I'm not an apostle. My nuts hang low, long and they're colossal. Black trader black, she messiah to the misfits. Run circles, run these rappers till my shit splits. You a little late to the party, baby, I been lit. If you ain't on the friend list, you better mind your business. Got the party jumping like crisscross. Got the gold chain and the wristwatch. Pull up on the scene like a big shot. EDM and hip hop, ain't no time for pit stop.
Got the party jumping like crisscross. Got the gold chain and the wristwatch. Pull up on the scene like a big shot. EDM and hip hop, cause my style. ice in my veins and a cold flow. I'm getting cash overseas by the boatload. You wanna ride my wave? That's a no-go. Senoritas going loco. Make it bounce like a pogo. All my haters see rojo. They big mad cause they coming up short like Frodo. Activate the beast mode. I keep it hot, give your brain a heat stroke. You ain't a big shot, you some basic B-roll. The world is mine like my name's Pacino. Hey, it's Nico, I guess I'm back. Catch me in the fast lane on the right track. And my shorty is a 10 like a dime bag. Got me feeling like a millie, check the price tag.
Got the party jumping like crisscross. Got the gold chain and the wristwatch. Pull up on the scene.
Hello. Second. Hello, am I audible? Okay, so sorry for the delay. So welcome everyone. My name is Saumil Petlia. I am from IIT Roorkee, and this is the first lecture of the ICPC Camp Div 2. So in this lecture we will be covering three main topics. It will be ternary search, meet in middle, and the constructive algorithms. So let's start with ternary search. Okay, so ternary search is it's like a quite very similar concept with binary search. So what binary search, what we do is like we continuously like divide the search space. We continuously reduce the search space from a particular L comma R to by finding a midpoint and reducing the search space by half. So that's a similar concept that is used in ternary search. So it can be regarded as a divide and conquer technique over the unimodal functions. So one thing to note is that binary search also, we only apply binary search when something monotonic is there, either increasing or decreasing, or some property is monotonic. The same thing can be seen here. The ternary search is only applicable over the unimodal functions. So let's see what are unimodal functions. Okay, so suppose we have a function f which is defined from L to R, and we regard f as a unimodal function if it has exactly one turn in the monotonicity across the interval. So basically the function f is unimodal. Then it can be two cases can be possible. Either it can be concave or it can be convex. So let's consider the first case, the case of maximum one. So suppose we have a function f and we are only considering an interval L to R. Suppose the function f initially strictly increases and it attains a maximum value, and then the maximum value can be at a point or it can be on an interval, and then the function strictly decreases. So this type of function we said to be concave, and by seeing the inequality we can see that there exists a point x star such that f1 till 1 to x star the function is strictly increasing, and after which attains a maximum and it is strictly decreasing. So that's the case of maximum. And similarly, we can say that if a function is convex, like the function first strictly decreases, it attains a minimum value, and then the function strictly increases. So it will be convex function. So concave functions and convex functions, these are two unimodal functions. So first of all, before applying ternary search, we must check whether the function is unimodal or not. So that's the first criteria that we must check before applying the ternary search. Okay, so now let's understand what actually ternary search is. So suppose we have a function which is defined from L to R, and so in this case, suppose we are assuming the function to be something concave, and suppose it has attained some maximum value at capital M. Now basically we want to find out the value of the maximum value of the function. Okay, so first of all, we know the function is concave. The naive way will be like to just iterate from all the point from L to R. So we have the interval L to R, and we can simply iterate about all the points. It's a naive solution we can consider, but we want to do it better. So we can do it more optimally by dividing the segment LR into two midpoints. That is, basically we are dividing the segment LR into three approximately equal parts, M1 and M2. So M1 would be L plus R minus L by 3, and M2 will be R minus L by 3. Now we calculate the value of function at M1 and M2, and based upon the value of the function at M1 and M2, we reduce our search space. So let's see how. So we have three cases. We first of all find out the interior points M1 and M2, and then we evaluate the function and value at M1 and M2. Let's say fm1 is less than fm2. Okay, so we have the points M1 and M2. So M1 is less than M2 is given to us, and suppose fm1 is less than fm2. So let's suppose the function is something like this, and let's say maximum is attained at a point capital M. Now if M1 is on the right of capital M, let's say M1 is somewhere here, then obviously as M2 is greater than M1, M2 will be somewhere here. But in that case, fm1 would be greater than fm2, which is not the condition. The condition is fm1 less than fm2. So this means that M1 must not be in the right part of the maxima. So I can say that M1 must be less than the point of maxima. Now as M1 is less than point of maxima, I can reduce my search interval LR to the search interval M1, R, because we are sure that the point of maxima will lie on the right of M1. Okay, so that's the first case. We have reduced the search interval from LR to M1R. Now similarly, other two can be handled. That if fm1 is greater than fm2, then we can reduce the search space from LR to LM2, and if fm1 is equals to fm2, we can reduce the search space to M1, M2. Now how this reducing is helpful, because you notice that let's say the length is, let's say, alpha. So as we are choosing M1 and M2 to be such that this is like three equal parts, so if you consider M1, R, the length of this will be 2 alpha by 3. So basically at each step we are reducing the length by 2 by 3rd. So at most there can be only log n steps, and in log n steps we will get our point of maxima. So that's the main benefit of this ternary search. Instead of iterating upon all the points from L to R, we are basically reducing the search space at each step, and we are able to find out the point of maxima in a better time complexity, which is order of log n. So basically, if you want to see the runtime analysis, that is Tn is the time complexity for the, suppose the length of the interval is n, then it will be Tn will be something like T of 2n by 3 plus order of 1, and when we solve this, it's order of log n or theta of log n. Okay, so log n are the number of steps. So overall time complexity, we see that we are assuming that the time complexity in finding the value of f is order of 1. So the better way to say is that overall time complexity will be order of, let's say x is a time complexity for evaluating the value of function into log of n. Okay, so that's the main thing. Okay, so this was ternary search. I will give you the code afterwards. Before moving to next things, these are some of the like quick test of unimodality that you can use. So these are some of the properties that comes handy in problems. Like suppose first property is that the maximum of linear functions is convex. Okay, so suppose we have f1, f2, f3 and fk. These are suppose k linear functions. Then if we take gx to be the maximum of all these linear function, then this gx will be a convex function. And similarly, if suppose f1, f2, fk are some linear function, if we take the minimum of all of them and make a new function gx, then g will be a concave function. And the third one is that the sum of mod of linear functions is a convex function. Okay, these are like pretty trivial to see. Let's suppose we want to see the property number 1. Suppose we consider a function gx, which is somewhere like, suppose it's max of 2x plus 2 comma minus x minus 1. So if you try to plot this thing, so it's like max of 2x plus 2 and minus x minus 1. It will be somehow like this one, and the other is 2x plus 2 is this part. So if we take the maximum of this thing, so this will be the function gx. So you can see that the function g is a convex function. So similarly, you can prove the other properties, that max, minimum and the sum of mod of linear functions. Remember, the mod is the absolute value here. So these three properties can help in some of the cases, in some of the CV problems. Okay. Now come the implementation part, that how actually we are going to write down the code. Now the function f can be defined on a discrete domain, or the function f can be defined on a continuous domain. Okay, so if the function f is defined on a continuous domain, then we have to define some threshold epsilon, such that whenever r minus l is greater than epsilon, we have to loop until the difference is large enough. So the preferred thing is that you can run a fixed number of iterations, around 200 to 300, and since the interval shrinks by 2 by 3 at each step, so approximately 200 iterations will guarantee the precision. So we will see the code afterwards, but yes, you have to reduce we know that at each step the length is reduced by 2/3. So approximately like 200 to 300 iterations will suffice, like it will reduce the length by a good amount of factor. And suppose in most cases it will be discrete domain. Suppose LR is a discrete domain, that function f is defined only on integer points. Then you have to stop when r minus l is less than 3. Because if you don't stop at r minus l less than 3, it can lead to infinite loops. Because suppose r minus l is suppose is 2, then m1 and m2 both will be equal. And the length, like the length of interval will not be reducing, it will be like same at each loop, it will lead to infinite loop. Okay, so when r minus l is less than 3, you have to stop, and then you can manually check for all L to R that which point is giving the maximum or the minimum value. So that's the case of discrete domain. So you can see the implementation part here. We have function f. We will define the function f here, which will be calculating the value of f at a double value x. Now that's the main code, the code of ternary search. We are doing some fixed number of iterations, let's say 200. You can change it according to the problem, and we do iterations, and we calculate the value of m1 and m2 at each step. And if fm1 is less than fm2, then we simply let L2 be m1. If fm1 is greater than fm2, R is m2. And finally we return the value of L. That is, we will get the value of the point of maxima. So that you can implement for the continuous case. A similar implementation can be done for the discrete case. Okay. So that's one practice problem. It's from CodeChef. You can try upon this. The link is given. Okay, so you can try upon. Let's dive into the solution. So first of all, let's understand what the problem is. So basically there are n programmers and they have decided to do a car race, and the ith programmer is basically at a distance ti ahead of the starting line at time t equal to 0. So basically at time t equal to 0, all the programmers are at a certain distance from the starting line, and the speed of the ith coder is given to as si. And after the time t, we are given the position of ith coder as something like si into t plus di. Like it's obvious that initial distance plus time into speed. So after time t, the position of the ith coder will be this thing. And the main thing is that we define a function f, which will be a function of time, which is like the max of pit minus min of bjt. Okay, so the function is defined in such a way that it's max minus min. So basically at time t, it is like what is the distance between, what is the maximum distance between two cars. That's the value the function f of t is giving. And we know that the race is ending at time t equals to capital K. So we just need to find out basically what is the minimum value of f of t during the whole race. Okay. So I think the question is clear. Let's see how we are defining the function f at a particular time t. So suppose we have function f, and basically at time t is defined as it's max of pit minus min of bjt. So if you consider max of pit as all pi's are linear functions, and all pj's, like they are also linear functions. So if you can see the max part, so we have something this max part. So max of pit is something like max of s1t plus d1 comma max of s2t plus d2, and so on and so on. So it is max of s1t plus d1 comma s2t plus d2 and so on and so on. So obviously we see that this is a convex function, and if we see the min part, so if we see the min part, so it will be the minimum of linear functions, and we know that the minimum of linear function is a concave function. We have seen here that the minimum of linear function is a concave function, and because we are taking negative, so we know that the negative of a concave function is a convex function. So overall f of t is nothing but sum of two convex functions, and sum of two convex functions is again a convex function. So basically that's the way we can prove that f is a convex function in terms of t. So f is basically a convex function of time. Okay, so as it is a convex function, its shape would be somehow like this, and we are given that the interval is as it is defined is 0 to k. So there will be a point at which it will attain a minimum value, and as the function is convex, you can apply the ternary search, and for that you just need to apply ternary search code and you will be done. One more thing is that the function f is basically, here the function f is continuous, at time can be continuous, so we have to like see upon this type of code, that is fixing number of iterations and continuously shrinking the search interval. So that's the idea. Basically we'll apply ternary search from 0 to k and we'll find out the local minimum for this. So let's see the code for this part. Okay, so that's the code. Basically we take the nk as input, and we take the speeds and the initial distances as input, and we are doing 200 iterations, and at each iteration we calculate the value of m1 and m2, and after which we calculate the value of the maximum distance and the minimum distance, and we calculate the value of the function f1 and f2. So what is f1 is? F1 is the value of function at m1, and f2 is nothing but value of function at m2. It's value of function at m1. Now we just compare the values. If f1 is greater than fm2, low is m1. If f1 less than f1 less than f2, then high is m2. Otherwise low is m1 and high is m2. So that's the main idea. Now continuously this low is initially low as 0 and high is k, so we'll continuously shrink the interval, and we will finally shrink the interval L to R, which will be like pretty much close to the point of minimum. Then we just take the minimum of this, because we have low to high will be like a very small range which will be containing the minimum point. So for sake of better approximation, we take the average of that and we just calculate the value of function at this particular point, and then we just output that thing. So that's how we can solve this problem. I think it is clear to you. Let's see the chats. Okay, So we can move forward now. So one more thing is that it is not always mathematically easy to prove the unimodality, because in this case we can see the function f was simply a combination of linear function. So we were able to prove the unimodality very easily. But in some cases it is not possible. It is possible, but it is not like easy mathematically. So we can just try upon some small values and try to build upon the graph. And if you see some convex or concave type of thing, you can try to apply the Ternary search. That's some idea behind that. Okay. Some more problems will be there, which will be included in the homework mashup, which will be given after the session. So let's move to the next topic, the meet in middle. Okay. Okay. So meet in middle is like, it is not containing any theory. It's just a technique that we use to solve problems in which there are some special type of constraints. We will see what constraints we are talking about. But keep in mind that it is problems which involve the dividing the search space into two. So basically what we do is like, the overall brute force solution is not feasible. But what we do, we divide the whole solution into two parts. We apply the brute force on each part, and then we somehow merge the two parts. That's the idea behind the meet in middle technique. Okay, so we'll directly start with the question only. It's a CACS question, meet in middle. The name is also meet in middle. Okay, so in this question, we are given an array of n numbers, and we have to find out in how many ways can I choose a subset of numbers with sum equals to x. Okay, so we are given two numbers n and x, and we have n integers t1, t2, t3, tn. So we have to find out how many subsets are there which creates the sum as x. So if we see the constraints are like n is up to 40, the values, the x value is up to 1e9, and the values of the array is also up to 1e9. So how we can approach this problem? One thing is that we can't use dp here, because the value of t is like very large. If someone is thinking that we can create some dp state, it's dpij, something like that, that how many subsets are there up to considering the first I numbers with a sum of j. It is not feasible because the constraints are pretty much high here. So dp is not applicable here. So one way would be like, we iterate upon all the subsets and then iterate upon all the subsets by using the bit mask, and then see which subset are giving the sum x. Okay, so the naive approach will be something like that. That is, iterate upon all subsets and then just see if the sum of the subset is like x, then what simply we do count plus plus. But if you see time complexity of that, it would be order of n into 2 raised to power n. And if you see the constraints of n is here 40. So this is actually very slow. So we can't apply the following method here. Okay, so that's where the meet in middle idea comes. What we actually do, we have suppose array of n numbers. So we divide this array into two equal parts, approximately equal parts. Now each of n by 2, and we do the brute force that the particular naive solution in each of this subpart, this part and this part. So basically what we are doing, suppose for this part we are ignoring this particular part, and we just find out, we create a hash map h1 which will be like storing how many subsets are there with a particular sum. So like there will be two hash maps. One hash map will be h1 and another hash map will be h2. So h1 would be storing like sum versus count. For the first half, and h2 hash map will be storing sum versus count for the second half. Now how we can do this? We can simply need to iterate upon all the, like we consider the mask of length 2 raised to power, like up to 2 raised to power n by 2, and we consider all possible subsets, and we just see a sum of the subset, and we just increase the count of that by 1. So we can create the hash map h1 which will be like the sum versus like how many subset has that particular sum. Same way for h2, we can create a hash map for this particular half, that how many subsets have what sum, like sum x comma count. So after which we have created the two hash map h1 and h2, we can try to merge the two hash maps. Basically what we will think, we will try to merge the two hash maps. What I mean by merging is that for each element in the hash map h1, suppose it is something like a particular sum, and suppose there are, let's say, alpha subsets which are having that sum alpha, like sum as sum. So as we want the total sum to be x, we will search for the key x minus sum in the hash map h2, because we want total sum to be x, and suppose it has value beta. That means there are exactly beta subsets with the sum of x minus sum in the h2, in the second half. So we can simply do alpha times beta, and we can simply add alpha times beta to our answer. I think the idea is somewhat clear. What we are doing, we have an array, we divide into two parts. We do the naive part we solve the problem for the first half. For the second half, we create the hash maps independently, and for each hash map we would have sum comma alpha, that how many subsets are there with the sum of a particular sum, and then we just need to consider the complement, that is total sum we want to be x, that how many x minus sums subset sum are there in the hash map h2, and we simply like alpha times beta we will get, and we simply add the alpha times beta to our answer, and summing this over all the subsets, we will get the final total subsets having a sum of x. Okay, so that's how we do this. So basically the meet in middle technique can take advantage of smaller constraints, and we calculate a naive solution in the two halves, so therefore the constraint tends to be double. Let's analyze the time complexity of this. So if we see time complexity, we know that we splitted the array into two parts, and for each part the length was approximately n by 2. So we run a naive solution on both of them, so it will be 2 raised to power n by 2 into n for calculating the sum. So that will be the time complexity for this case, and as n is 40, so this can easily pass. So that's the idea behind the meet in middle technique. I think the concept is clear. If there any doubt, you can ask in the chat. Okay. So let's see the code of that thing. So that's the code. So what we do, we take input nnx. We divide into two parts. One will be of length n by 2, other would be of length n minus s1. And basically at the input time only we are like taking the separate inputs. So that's the input we take. Now we do a naive solution for we do a naive part for the first thing. What we do, we have a mask of up to 2 raised to we have up to 2 raised to power s1, and for each mask we calculate what is the actual sum for that particular mask, what the particular subset sum that mask is representing, and we just add that particular subset sum to my sum1 array. We do the same thing for the T2 part. We just iterate upon all the mask up to 2 raised to power s2, and then for a particular subset sum we simply push that particular subset sum into my vector sum2. So we have sum1 and we have sum2. So sum1 will be storing all possible subsets of first half, and sum2 will be storing the all possible subset of second half. Then we just sort the sum1. Instead of making hash maps, we are using, like, we are simply sorting the array, because in CSS if you try to submit the hash map solution might give a TLE, so it's better to use simply vectors here. So now we simply iterate upon all the subset sum of sum1, and we try to search how many x minus sum1 at I is there in the sum2 array. Basically, how many x minus sum1 I are there in sum2 array. So that here we want to find out. So we just see the lower bound of x minus sum1 I, and we take the upper bound on x minus sum1 I, and we simply add the answer with how many x minus sum1 I are there in the sum2 array, because one total sum to be x, and we can simply output the answer value here. So that's the code of that thing. Okay. So there is one more problem on meet in middle. So you can try upon this also. The idea is very much similar what we use in a previous problem, but somewhat some additional touch of solve. So link is given, you can try upon, you can read the problem for a while. Okay, so what's actually the problem say? We have a rectangular grid of size n cross n, and each cell has a number written on it, and number on the cell ij is aij. So what we need to find out, we need to find out the number of paths from the upper left cell 1 comma 1 to the bottom right cell n comma m, such that first thing is that you can only move right or bottom. Okay, so at each step from I comma j you can move to I comma j plus 1 or I plus 1 comma j, and we can't move outside the grid. And the second main condition is that XOR of all the numbers from 1 comma 1 to n comma m must be k. Okay, so that's the question, and we have to find out how many paths are there from 1 comma 1 to n comma m, each moving right or down, such that XOR of all the values encountered is exactly k. So we need to print number of such paths in the grid. And if we try to see the constraints are nm is 1 to 20, and k is 180. So first of all, how we can approach the problem, like wait a minute. Okay, so first of all, at each point we have two possibilities, either to move right or to move down. And if we try to see brute force, like we try to do brute force, like we consider, let's see, first of all understand what is the length of the path. So basically we are starting from 1 comma 1, and we are going towards n comma m. So the path will be something, each step we move right or down, right, down, and somehow we reach n comma m. So basically at each point we have two possibilities, either to go right or to go down, if it is a valid thing. So what will be the total length of the path? Total length of the path will be n plus m minus 2. Why is it so? Because the total number of right we have to take is n minus 1, and the total number of down we have to take is m minus 1. So total length of the path would be n plus m minus 2. So one way is that, like we represent right by 0 and down by bit 1, and we consider all the submask bits which are of length n plus m minus 2, each will be either 0 or 1. So 0 means we are taking right, and 1 means we are taking down. So there will be 2 raised to power n plus m minus 2 total number of masks possible, but all will be not be a valid thing, because we should be reaching n comma m at the end of the path, and we should not be going out of the grid at anything. So out of this, some will be valid, and then we can simply consider that and find out the XOR value, and like simply naive solution, we can just create a hash map batch, calculate the XOR value, and we'll simply do a count plus plus for that particular XOR. Okay, so let me repeat the naive solution. It is like at each step we have two possibilities, either right or down. We create a, like we represent right by 0, down by 1, and then we will have a mask which will be of length 2 raised to power n plus m minus 2, and we consider all possible paths, calculate the XOR value and increase the count of the particular XOR value. Like if it is XOR value is equals to k, then simply you can do count plus plus. So if you see the time complexity of this one, it will be order of 2 raised to power n plus m minus 2 into n plus m, because we are considering all possible paths. But actually if you see the constraint, n plus m can go up to 40, so it is not feasible, it is like very slow here. So idea is similar. What we will do, we consider the path from like this point to this point. It will be somewhere like this. So we will divide the path into 2 parts. So basically we will divide the path into 2 parts and then try to do a naive solution on each of the part. So total length is n plus m minus 2. So we divide into 2 parts, let's say of length s1 and s2, and then suppose basically the path from 1 comma 1 to n comma m can be break down into, let's say this meeting point is, let's say r comma c, and the length of this part would be so length of this part would be s1 and length of this part would be s2. So we divide the part into 2 parts, one would be of length s1 and other would be of length s2. So the path from 1 comma 1 to n comma m, we are breaking that into a path from 1 comma 1 to r comma c and r comma c to n comma m, or equivalently n comma m to r comma c. Okay, so what we are saying, the path can be break down into the path from 1 comma 1 to r comma c plus a path from n comma m to r comma c. Okay, so and the length of this should be s1 and length of this should be s2. Okay, so solution would be simple. Like what we will do, we will consider all the path of length s1 starting from 1 comma 1. Starting from 1 comma 1, we will consider all the path which are of length s1. Okay, so it will be like creating a mask of length 2 raised to power s1 and seeing whether it's a valid or not. If it's a valid path, then we can simply calculate the XOR value and we store that what is the endpoint r comma c and what is the corresponding XOR value of all the values encountered, and we simply create this type of triplet, like it's a path of length s1 ending at r comma c and having the value of XOR as xr. Now similarly we can do for the second half. We will calculate how many, like we will consider all the paths starting from n comma m and of length s2, but difference is that in this is at each step it will be moving either left or up. So that's the same thing. So what we will do, we will have 2 s2 power s2 paths. Basically we'll be having somewhere around 2 s2 power s2 paths, and for each of this path we would be having something that whether it is valid or not. And we'll be having some endpoint r comma c and some XOR value encountered xr. So that will be the two halves. So we like create some hash maps which will be storing the endpoint and the XOR value both from 1, 1 and n, m. Now suppose now like that's the idea of meet in middle. If we divided the problem into two parts, now we need to merge this thing. So what actual problem asks is that how many paths are there which have a XOR value of k. So suppose we have a triplet xr1 and let's say we have a triplet xr2. So basically if we want the XOR value to be k, then we need at xr1 XOR xr2 XOR arc, because this is counted 2 times. This should be equals to k. So for all these like pairs of triplets satisfying the following condition, we simply add their product of count to our answer. So that's the main idea. And if you see the time complexity of the solution here, basically it is order of 2 raised to power n plus m by 2 into n plus m. Because like s1 and s2 are of length n plus m by 2 and we just need to merge the two things. So we can do like this. You can try upon, you can try to do an AC on that question. Let's see the code, you will be more clear. Okay, that's the code. If you want to see the problem code, it is code forces 1006F. You can search this problem and like you can assess the problem. Okay, so let's move into code. So if we take n, m and k as input, and then what we do is that we take the array as input. Now we will create a hash map. It will be like a little hash map, a 2D hash map. So basically Vij will be like how many paths are there from 1, 1 to I, j, and Vijx, it will be storing that how many paths are there from 1, 1 to I, j having a XOR value of x. So that's what the function calculate LF is doing here. It's like starting from x, y, and suppose the count is the is the length of the path we have encountered, and what is the value of the XOR till now. So simply we do val XOR axy, like it is considering the current value, and if count is half, then we simply increment the counter by 1, And if the count is not half, then we have two choices, either to move right or down, and we simply call the function for this. So this will be like filling the hash map. So basically this will be filling the map. Now the final answer part, what we will do is that it will take a, like it will like iterate upon all the paths which are starting from n comma n. This will be like paths starting from n comma n, and it will be like to till x comma y, and if count is s2, which is n plus m minus 2 minus half, then we simply see the hash map and how many values are there for k's or value, and we simply increment the final answer by that particular value, which is the count of for 1 comma 1 to a particular cell, and then we simply consider either we can move left or we can move up, and that's how we can iterate upon all the paths from n comma m to some other thing, and finally we call the two functions, and then we finally print the answer. So that's the main thing, that like that's how we can solve this problem. You can think upon more and try to find out in, like, try to code it yourself and try to get an AC. But that's the basic idea. We divide the path into two paths, one from 1 comma 1 to a particular cell and n comma m to a particular cell, and we try to merge because we want the XOR to be k. We can just merge the XOR. So that was all for this thing. Now we'll move to the next topic. For homework questions, we'll be giving a mashup that will be like containing the practice problem for all the topics covered in this session.
Uh, So hello guys, I'm Karthik Rao and I'm also a fellow student at ITR. So the next topic that we'd be start covering is basically constructive algorithm. Constructive, like what would you consider constructive algorithms? It is basically the set of problems that do not have a well-studied solution, right? Like you cannot just learn an algorithm, study an algorithm for it, and could convert that problem into just application of that algorithm, right? So it basically involves a creative side of competitive programming, right? So here, like you couldn't be prepared for all of the constructive problems there are. You would have to. The only way to get better at constructive problems or ad hoc problems in general is just to practice and practice. Like there is not a simple pipeline to just not a simple pipeline that could be applied to all of the problems. Here I have discussed a few points which you should keep in mind if you are stuck at some problem. Like it is basically a structured guide to which would help you think outside the box. So the first thing that I'd suggest keeping in mind is to is to just start on small cases. Like you must have read about how we could prove a theorem by induction, right? Well, while proving with induction, what we try to do is we start on we establish a base case and just keep on adding, like keep all of our, like keep on recording the observations we get, and then try to prove it for larger n's using the info we get from smaller n's, right? So this is a method like you would use for proving by induction. This could also be applied when like in a lot of ad hoc problems. You could just find pattern or some good observation from smaller cases which you would find handy for larger cases too, or you could just generalize. It also helps when you are just debugging your code. Just input a lot of small test cases, and they just help you quite well. The second part is just writing down the observation. Sometimes you'd get an observation and just not use it. So that just wasted your time, and you might just even not end up solving that problem altogether. So it is always handy to keep your ideas together in a structured way. And the second thing is like you do not need to like a main way to solve these ad hoc problems is to just come up with a lot of ideas. Some would work and some would not. That's how you'd end up solving. That's how you think outside the box, right? You just brainstorm a lot of ideas. And the next thing is just I would say just use the creative side, not just try and think about a standard algo and try to apply it everywhere. You would want to enter your creative side where it would where you are just brainstorming and throwing in ideas. Some might work, some might even seem ridiculous, but that would actually help you improve or at least get some observation. So as I mentioned, that the way to get better at ad hoc problem is to just do a lot of problems. So that's what I'd be doing from now. I'd be like this is also a ad hoc problem. If you read it, it would seem a bit different, like complicated at first, but it is mainly because you are using bitwise operation as well as number theory in the same problem, right? So this is also like so this is where you would have to use your creative side. So I just want you to read the problem, then we'd proceed with the solution. It is available on Code Courses, by the way. So I think if you haven't read, you want to read it or try it, I think you should pause the stream. The next, so let me just first clarify the problem for you, like break it down. Here in this problem you have n nodes, like for let's say n is equals to 6 we are discussing. You would have 6 nodes, right? 1, 2, 3, 4, 5 and 6, right? So for this and here we are creating an undirected graph out of these nodes. We are adding an edge whenever u XOR v, like the bitwise XOR operation of the numbers ends up being prime. So I'd like you to follow, if you are stuck or you want to go ahead with the solution, I just suggest that you try to keep in mind this checklist, right? To first start with small cases and just keep on jotting down your observations and just trying to apply it to larger cases, right? So first I'd like to discuss the case when there you have 6 nodes and you are just applying these operations. At the end, what we need to find is the minimum number of colors that we need to do on these nodes, such that each edge is like not directly connected by the same color, right? Both the nodes of the edge are not the same. So if we go step by step, first we'd see like where there are edges with 1, right? So the 1 would have edge with 2 because 1 XOR 2 is 3. It would not have edge with, it would also have edge with 3 because like 1 XOR 3 ends up being 2, and it would also have edge with 4 and 6, right? Similarly, I'd see for 2 would not have an edge with 3, 2 would not have an edge with 4, and 2 would have an edge with 5 only, right? And similarly, between 2 and 3, I'd see that between 3 and 4, I'd see that 3 has an edge with 4, and 3 also has an edge with 6, right? So here I'd see the minimum number of colors needed ends up being 4, right? Because you cannot obviously you cannot color it with 3 because you cannot color it with 2 because of this 1 4 3 cycle. And if you know a bit about bipartite graphs, you would know that to color a graph with 2, you cannot have an odd cycle. And secondly, for 3, you would see that you're just yeah, you can, like, suppose you color it with blue, let's say, and suppose you give this red, and you also give this red because you just want to minimize the colors, so you wouldn't throw in a new color now. And so there would also be an edge. You'd color this edge as green because blue and red are already connected. I think I'm missing an edge here because 1 3 1 2. Separate 2 and like you could just also see these test cases, right? That so the thing here is that you would observe that there's always an edge. Like if the problem was to consider the prime numbers greater than 2, then you would notice then there's whenever there is an edge, it is always between 2 odds, right? Or 2 evens. It is not between 2 odds or 2 evens because if you XOR 2 numbers with the same parity, you end up with an even number, and the only even prime number we know is 2, right? So the issue we end up, so the main observation we have here is that there's an edge between odd and even. Like most of the edges are between odd and even, and the next thing that we notice is if there is an edge between the same parity, it is only if u XOR v is equals to 2, right? So the next, so you would notice that when is u XOR v2, when there's only one bit that differs between the two, that is the second bit. So if you would write u's binary representation and same for v, you would notice that these bits are all the same, and the only place that differs is this second bit, and there'd be the first bit also is the same. So if you would notice the last two bits, you would see that the last two bits of u has to be 1 or v has to be 3, or vice versa, right? Or 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 it could also be either 0 and 2, right? The rest has to be the same. So what we could say from here is that I'm sorry. Like u mod 4 minus v mod 4, like u minus v mod 4 has to be 2, right? Mod 4 has to be 2, right? So this is the first observation that we could draw, but this is like, it does not mean that whenever u minus v mod 4 is 2, there would be an edge, right? It would also have to mean that the upper bits, the bits from third to all the way rest up ahead, would have to be the same for both u and v. So the thing that we could draw from this is there would be an edge only if the u minus v mod 4 is 2, or there is like an edge between odd and even. They are not the same parity. If they are the same parity, they're like they have to be, their difference of mod 4 has to be 2. So also another thing that we could note is another thing that we could notice for larger graphs, like for, let's say, I am defining fn, like let's say fn as the minimum number of colors, right? Minimum number of colors that satisfy our constraints. Basically the answer. Right, the minimum number of colors, right? So what we can do, we can gather from here is, like, if we know the value of fn, what could we comment about the values of this function when n is greater than the given value? So we could see that for larger graphs, there's always a subgraph of, for let's say n is equals to 8, there's always a subgraph of n is equals to 6, right? There would always be nodes from 1 to 6. So if we know the answer for n is equals to 6, it would, like, our answer would just increase, or rather say the same. So we could get from this is f m is less than equal to, is less than equal to f of n if m is less than, right? So it is kind of just, it is non-decreasing, right, the number of colors. So what we can say from this, like combining these two observations, we could say that like what are the minimum number of colors we could do, the number of colors we need to color all, right? So the thing here to note is we could just, we need to color all the odds different from all the evens, so that gives us with an answer of greater than equal to 2. Like we would need minimum 2 colors to do this, and also we need to make sure that this condition is followed. So we would need a minimum of 2 colors to do this too. So worst case scenario is we take 4 colors, right? We color every node, like if among the same parity we color the ones with mod 4 is equals to 0 or 1 with a different color, and the mod 4 being plus 2 with a different, right? So worst case we would need 4 colors, right? So the answer is always less than equal to 4. But here you would see that the answer for n is equals to 6 ends up being 4. So, and given the previous two constraints, we have already proven that f of n is less than equal to 4. So what we could infer from this at the end is that we need exactly 4 colors for all n greater than equal to 6. So the main trick in this question was to just start on smaller n and just keep on increasing, right? And just keep on drawing conclusions and keep on increasing. So what would our strategy be at the end? How we could color it? For n less than equal to 6, we could just brute force. Like we already have the sample case, so I don't think there's a need to brute force. But we could just find the suitable coloring, and for n greater than equal to 6, we could just color depending on their parity. Like we could color the odd ones with, like we could color 1 as n mod 4 is equals to 0. We could color 2 as n mod 4 is equals to 1. Sorry, n mod 4 is equals to 1, and similarly 3 as n mod 4 is equals to 3 is equals to 2, and 4 as n mod 4 is equals to 3, right? So what this would guarantee is if there is an edge between the nodes of same parity, they would also lie in different colors because they would have a different mod 4, and if there is an edge between odd and even, they already have a different color. So for n greater than equal to 6, we could use this approach, and for smaller n's, we could just brute force the answer. So moving on to this next question. This is also available on CF, and it is, by the way, an interactive problem. Interactive problems a lot of time require an out-of-the-box thinking. So they oftentimes lie under constructive algorithms. So I would want you to read this problem. If you are not aware of interactive problems, it is basically when you ask something to the jury and they would return a value to you. So it is basically like a question answer type. In this question, you could ask only 2 questions. In this problem, you could ask only 2 questions to the jury, and they would to the judge, and they would return you with the corresponding output. The output would be according to the constraint given, right? So I hope you've read the problem. I'd explain it. So here you have 2 hidden integers, x and y. And in this problem, what you need to do is you need to find m or x plus m or y. This is the bitwise OR, by the way. So what type of questions we are asking? We would just give an integer n to the jury, and they would return us with n or x plus n or y, right? So so at the end we need to find the value of m or x plus m or y. Note that we do not know m. M would be given to us after we ask these 2 queries, or no more than 2 queries. And the next thing that we have, and we do not need to find the values of x and y, like either x or y. You get? So in this problem, it requires, like you would see it and think that it does require bitwise manipulation. So I hope you are aware of it, like how we could do bitwise manipulations. So let's dive into the solution. Also, we could ask only 2 queries, right? So what does 2 queries like? To find the answer, we do need to comment on the each bit of x and y, right? Like the individual, for each individual bits, we need to comment on either it is present on x and either it is present or on y, right? Because finally when we need m or x plus m or y, we could, if we think of each of the bits independently, we could just see that we could just see that we just need to comment on the value of, like, if the bit is present in m and if the bit is present in either x or y or both. Like either the bit is present in one of x or y, both x and y, or none of these, right? Because at the end that's all that would matter in this case, because you could just swap the bits in x and y. Like you could just swap one of the bits in x and y and you would just still end up getting the same answer. So it doesn't actually matter if the bit is in x or the bit is in y. So to comment on this, like one of the observations that we would know, that if we just straight up query n as 1 1 1 1 1 or 0 0 0 0, we would get much information. We would just, in this case we would just get 2n, and in this case we would just get x plus 1, right? So to comment on the individual bit, we need to kind of separate the bits, right? We need to kind of separate the bits. So and also we need to get at least half of the information from the problem, right? Half of the information of all the bits among these. So what we would like to query here is that if you just do some trial and error, you would end up seeing that first of all, I'd like you to think about it for a moment. Like if you have any questions, you could ask it in the chat. Okay, so the main thing here is that you need to query the number 101010 here, and similarly for the other query you could just cast 010101. Why it would help is that you would get how each bit behaves independent of the bit ahead of it, right? So let's see for smaller cases, like for let's say 2-bit numbers, right? So suppose x is equals to 3 and y is equals to 1. Like these are all 2-bit numbers, right? This is 1 1, this is 1 0. like 0 1, if you would say. So if we would first of all query 1 0 here, for the first query, what we would get? We would get 2 or 3, that would be 3 plus uh, 2 or 1, that would also be 3. So we would get 6. So the output here we are getting is 1 1 0 6 for the first query. For 1 0 we are getting 6, and for 0 1 we would get 3 plus 1, right? That would be 4. 4. So if you would just see the first bit, if it is present in both, if it is present in if it is present in this query, if for the first bit, if it is present in this query would give you a value of 2, right? And similarly, this query would either way, if the bit is present in both or not, it would give you a value of 2 only. So any conclusions that we could draw from this? So here the wise thing to do here would be to just to start from the lowest bit and just keep on seeing how the rest of the numbers behave. So for only 2-bit numbers, we would see that if if the first bit is 0, let's say, if the first bit in both of the numbers is 0, we would just get 1. And if the first bit in, like, we would get 1 for Q1, and I'll switch to a new page. So suppose for the smallest bit we are talking, the odd or even bit. So for, if we would go from left to right, Q1 is, suppose, let's say 1 0 1 0 1 0, and Q2 is let's say 0 1 0 1. Like here I am talking about this is the LSB, because we are considering LSB as 1 here for Q1, and for Q, let's say 0, we are considering LSB as 0. So for the first bit we would be seeing if it is both 1 1, we would end up having 2. Like, let's say in both the queries, this bit would be 0, right? So if the bit is 0 0 in Q1, let's say this is Q1, I'm sorry, let's say this is Q1, this is Q0. So if it is I'm sorry, let me go. This okay, this is Q0. So if the bit is 1 1, we would get 2 2 from both of these, right? If the bit is 0 0, like if the bit is 1 1, we'd get 2 2. If the bit is 0 0, we would get, like, if the last bit is 0, we would get this is X, this is Y. if the last bit is 0 0, we would get 1 for q1 and 0 for q0. Similarly, if the last bit is 1 0, like for say either 1 0 or 0 1, it would be the same. If the last bit is 0 1 or 1 0, for q1 we would get for q1 we would get 2 only. Oh, here also we would be getting 2 only. So for q1 we would get 2 only, and for q0 we would get 1, and so you could see that for this case we would we have drawn 3 conclusions here. Like for each of the case we could just keep on finding the bits from LSB to MSB and keep on just incorporating each of these, right? So suppose for a larger number, and so with each of these cases we could just find if it belongs to this, it belongs to this, or it belongs to this. And if we are able to find, let's say, this much of the number, we would already know the value of this much of the number. Then we could just incorporate these and just subtract it to the q1 and q2, right? So we could just keep on with let's say we are at bit b, so from 0 to b minus 1 we could use these to find which case the bit b lies into. So so this is how it is. Also, so here instead of going from smaller cases, we are going from a bit of lesser length, like a number with lesser bit length, to a number with greater bit length, bit by bit. So I hope this is clear. So the next problem that we'd be diving into is basically constraint chopping. It is on Code Chef. I'd write the contest starters 2 3 1. So you could find it using this. It is in this contest only, where constraint chopping. So it is basically a game theory question, but why have I included it in constructive problems? Because here also you need to think creatively. Like there is no standard algorithm for these problems. So if you want to solve it on your own, I would suggest stopping it. And by the way, the constraints are not included here, but the constraints are 2e5 itself. So what the problem statement itself is that you are given an array. So you are given an array, and so the game goes like this: like Alice selects an index I, and Bob would either erase. So Alice is choosing the index, but Bob has a choice to either get rid of this part, or it could either get rid of this part, right? So at the end the game ends when the length of array is less than equal to 2. So the length of array is less than equal to 2, and what we are trying to do is, so at the end the Alice's score would be the maximum remaining element. So Alice is trying to maximize her score, but Bob is trying to minimize her score. So what we are trying to do is the largest value of the largest element that we could keep as Alice. Like, so assume that we are Alice, so we need to maximize the largest element left in the array, while Bob is trying to minimize, so we are playing against Bob. So the main thing in this kind of problem is that when you are trying to maximize the minimum or minimize the maximum, or in a situation like this where you are trying to maximize the maximum but the opponent is trying to minimize it, what the main thing that could help us in a lot of problem is basically thinking about it in a case where the array is just full of zeros and ones, right? So suppose that we have a binary array 0 1 0 1, something like that. So the main thing that would help us here is if we could so like at the end if we need to check if we could be left with 1, right? Because the maximum 0 1 ends up being 1 and we are Alice, so we want to see if for a given array we could find 1 in this or not. So here what instead of thinking from top to down, like we have an array and just we are applying the move, we should try and think about it from bottom to up. Like suppose that we could have 1 in the array. So what are the possible arrays that we could be left with? We could be left with either 1 or 0 1, 1 0 or 1 1, right? So basically we at the end we need to be left with either one of these 4 to be able to win, right? So if you think about let's call these strings S, these set of strings S. If we have a string that could that ends up being this in the set S, we would call it a winning string, right? Because we could always force Bob into reducing it to a string S. So what should be our array at the end? It should be S1. Suppose we are talking about the second, what should it be? It should be S1, S2 and 0, like a character C, right? How does this help? It helps because now we could, like we are Alice, so we are choosing the index, right? So we could just choose this C, and if Bob removes this, we would still end up winning because it is S1. S1 is here. Or if Bob chooses this part, we could still win because S2 is also winning. So at the end, what we need to check is can our string be representable with these strings? Like one of these, could it be represented in this form? Like some characters concatenated between our the basis strings. So main thing, so the thing that we could, well, if you would ask if how we could convert our original array into binary, so I would just say binary search, because if an element is greater than equal to k, you could just represent it as 1, or if our element is less than equal to k, you could represent it as 0. So our problem just reduces to applying binary search and checking if this string is winning. And how would we check if this string is winning? If it could be represented from this basis concatenated by some characters, right? So the last thing that, so lastly, how would we check if our string is winning? We could, I would just suggest using dynamic programming. Like if suppose you have a string, you know that your string till I is winning, you would just go to the state some arbitrary character plus string s1, like you would go to 4 states, right? So you would go to, from I you would go to either some character c times 1 slash 11 slash 01 slash 10. Right. So the next stage, so like if we know that our string till I is winning, only these are the possible strings that should be there if so that the index I plus 1 or I plus 2, like whichever the strings is, ends up being winning. So we could just write transitions according to these 4 strings and check if it is winning or not. So here the problem just reduces to using binary search and then just using dynamic programming to check it. So for each of the k, we would just check if the answer greater than equal to k is possible, like we would consider 1 as greater than equal to k, and our answer would be just the last index that ends up being no, the last index that ends up being a yes, right? So our answer here would just be dp of n, because we are just checking for the whole string at the end. And the thing here, like you would say that how did I come up with binary search? It is mainly because you could just see with practice that whenever there are problems involving median or problems involving like maximizing the minimum or something, you end up with binary search. So after the problem is reduced to 0 or 1, you just need to consider small cases here, like for answer 2, for answer 3, and just that ends up being dp. Here the dp is not that complicated, it is just checking these 4 conditions. And also this c could be arbitrary, like 0 or 1, anything, because we are at the end, Bob is just removing either this or this part, right? So why would I call it constructive? It is mainly because some would not, but this does involve game, but this involves thinking, like it does not involve any standard algorithm. It just involves a few, like if you have practiced enough, you would see that converting to binary just simplifies the problem. So that's why I have to incorporate this idea. I have included it in constructive algorithms. So I hope you were through with these topics, and if there are any doubts, feel free to post it in the stream, in the chat, like we'll be willing to take it. Also, we would be sending you homework problems like the homework mashup. So I hope with problems related to each of the 3 topics that we have talked about. So I really do suggest you to check it out and try the problems seriously. And so sure. So thank you. So goodbye.